Hello, let's create the transaction pool object. The job of this object is going to be collect transactions from various contributors over time in the overall blockchain network. So as usual, let's start building this new functionality with a test. We're going to go in the wallet directory and make a new transaction-pool.test.js file. All right, nice. First up, we're going to be Sidekick as usual and require a transaction pool class that does not exist yet, but we know that we're going to make this in the future as soon as our tests are done and written down. Cool. Now this transaction pool is going to consist of various transaction objects. So we should make sure that we can create those transaction objects, which means that we should also have a reference to the transaction class. So make sure to require the transaction class from the transaction file as well. We'll also require the wallet class, as this has a create transaction method that we can take advantage of. Cool. Now let's describe the overall tests, which are going to be for a new transaction pool class. All right, nice. Then let's create dynamic variables for the parts of the transaction pool that we want to test. First up, that is the overall transaction pool itself. Let's make a transaction pool variable. And then the transaction pool is going to consist of transaction objects. So to run a proper test, well, let's make sure that we have a transaction variable also available. Before each of the following tests that we're going to write, let's make sure that the transaction pool and the transaction are set to some proper instances. So before each of these functions, let's set the transaction pool to a new instance of our transaction pool class. And then this transaction, we can make an instance of the relative transaction class. And this takes in a sender wallet. And in this case, we want an instance of the wallet class above. The recipient can be anyone, so how about fake recipient as the value? And the amount should be anything as long as it's valid, so 50 should work. Cool. Now, similar to the output map for a transaction itself, we can use a strategy to maintain the transaction pool's data through a map-like structure. We're going to make an inner map in the transaction pool called transaction map. Now, the main advantage to using a map is its key value structure. So this offers great benefits like storing unique items in the collection, as long as you use the same key for that item every time. An array, on the other hand, has no immediate benefit and support for preventing these kinds of duplicates. So if you use the same item within an array, well, you're probably going to push to the end of that array, and you're not guaranteed that it's going to be a unique set of transactions. Whereas if we set a transaction by its ID within a transaction map every time, when that transaction is actually updated, it's going to overwrite its previous stored value within the transaction map, as long as, again, we use that same transaction ID. To acknowledge this, the primary way we're going to add a transaction is through a method called setTransaction. Let's describe this method with a group of tests that has the method name of setTransaction. And setTransaction is going to have two primary behaviors. First up, it's going to be able to add a transaction. So let's test that. It adds a transaction. Cool. And in this test, the first line that we're going to call is the setTransaction method. So this setTransaction method is going to be within the transaction pool. So use the transaction pool instance, call setTransaction. And because of our naming, it seems like what should be passed is a transaction object itself. So that's what we're going to do. We're going to set a transaction by passing the transaction object. Cool. And now as a result, we'll expect that the transaction pool has successfully added this transaction to its transaction map. So our actual value is looking at the transaction pool.transaction map. And we want to find whatever is located at the transaction ID in this map. And then this should be equal to the transaction object itself. Nice. However, beyond this, rather than the toEqual method, we can be a little more precise when we use the toBe method. Now, previously, we've been using toBe as an idiomatic expression to make expectations for the true or false Boolean, which just makes things sound nice when you expect a Boolean value to be true or false. However, the true power of the toBe function is a little more to this when it comes to objects. Now, there's a big difference between to equal and to be in Jest when it comes to objects, because with objects, to be tests that the actual value is the original instance of that object. To explain why this is crucial, recall that when we worked with the CryptoHash method, we made sure to stringify all of these inputs. And the reason was that one of these inputs could be an object. And even if the object's properties changed, so its key value structure format changes, JavaScript is still going to treat the same exact object as an identical piece of information and therefore create the same hash every time. Again, even if those properties change. And that is because it is the same underlying JavaScript object that is coming into the overall hash function. Now with the transaction_pool.test.js file, we're now testing this concept. We want the transaction in the pool to be the exact transaction object that we're passing into the function. Recall that analogy where there can be multiple nicknames for the same person. Now, just because the nicknames for that person are different doesn't mean that the underlying person is different too. All right, back to the code. So this actually completes the primary test for the transaction pool in terms of its setTransaction method. This addTransaction class is actually testing that the transaction can be set within the transaction pool, which covers both adding and updating that transaction according to its ID. So with that, make sure you're in the command line and fire the npm run test command if you don't have it going already within the project. So that is npm run test. All right, nice. The first thing that you'll notice is that transaction pool is not defined. So this is a scenario that we're familiar with. We need to make the transaction pool class in a transaction_pool.js file and then export that. So let's make the transaction pool. This is going to have its constructor, which creates a transaction map. So set this.transaction map to an object. And then the final line is to call module.exports equals this transaction pool class. Go ahead and save this. And you should see that, well, the next thing is that we need to create the setTransaction method. So in here, let's make setTransaction. And as the parameter to this, we have a transaction object. And the result is that we want to set this transaction in the map according to its ID. This.transaction map, and then we're going to access a new property in the transaction map by transaction.id is going to be equal to the transaction coming into the method itself. All right. And as we're saving this, we have a fully passing green test suite again. Cool. So this covers the transaction pool and the first setTransaction method. Nice. So again, a free benefit of this implementation is that it both adds a transaction and it can even handle transaction updates because it uses the same transaction ID. Pretty cool stuff. Now that we have this transaction pool, let's actually put it to use in the application. We're going to create a main instance of this transaction pool for the app in the index.js file. And on top of that, we'll also provide a new endpoint to allow users to see the transactions that are in this pool with a request. So let's do that next.